Hi everyone. When we ended class on Tuesday, we still had a couple examples left to work out in the circle section of our notes, so we're going to finish those first. Now, the problem where we left off says give the equation of a circle with a diameter that has endpoints -6, -3, and -10, 4. Remember that when we write the equation of a circle, we need to know the radius, and we also need to know the center of the circle. They didn't give us either in this case. Okay? So, let's find the center of the circle first. Now, because we're trying to find the center of the circle, we're going to use the midpoint formula. Okay, so remember that with the midpoint formula, we need to find the average of the x's and we need to find the average of the y's. So we add up the two x coordinates, divide them by 2, and we add up the two y coordinates and divide them by 2. So we end up with -6 plus -10 divided by 2, and -3 plus 4 divided by 2. That's going to leave us with -16/2 and 1/2. And now -16/2 is going to simplify to -8. So that's the center of our circle. So when we go to write the equation, your -8 is going to be your h, your 1/2 is going to be your k. Now, the other thing that we need is our radius. Remember that your radius is half of your diameter. And since we know the endpoints of the diameter, we can find that using the distance formula. So, find diameter using distance formula. So remember that our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So when we have the point -6, -3, and -10, 4, we're going to plug those in as x1, y1, and x2, y2. So the distance is going to be equal to the square root of -10 minus -6. Now remember, when we subtract a negative, it's really like adding. Plus 4 minus -3, but again, subtracting a negative is really the same as adding. Okay. This gives us the square root of -4 squared plus 7 squared, which gives us 16 plus 49. So we find that the diameter, the distance we just found, is the square root of 65. But we don't need the diameter, we need the radius. So in order to get from diameter to radius, we need to divide by 2. So that means our radius is going to equal the square root of 65 over 2. Okay. So now we have our radius and we also have our center. Okay. So we figured out that our radius was the square root of 65 over 2, and we also figured out that our center of our circle, HK, was the point -8, 1/2. Okay. Now, remember the equation of a circle is r squared equals the quantity x minus h squared plus the quantity y minus k squared. Okay. So, if we plug this in, the square root of 65 over 2, when we square that, is going to become 65 over 4. When we square the square root of 65, that's just 65, and when we square 2, that gives us 4. This will equal x minus negative 8, but again, subtracting a negative is the same as adding, plus y minus 1/2 squared. Okay. That right there is the equation of the circle with a diameter that has endpoints -6, -3, and -10, 4. So remember, when you're finding equations of circles, you always need that center point and you always need the radius. If they don't give you those, you do have the tools in order to find them out. Okay, let's take a look at our next example. The next example says to give the equation of the circle with center at -5, 3, that is tangent to the x-axis. Okay. Now, if you're wondering what that word tangent means, tangent to the x-axis means that it's just going to touch the x-axis at one point. Okay. Now, remember, we need the center of the circle and we need the radius. They tell me that the center is at -5, 3, but I still need to figure out what the radius is. Now, in this case, I've given you a little hint to sketch the graph. Okay. So we know that the center of the circle is at -5, 3. Okay, so it's right there. And that the circle is tangent to the x-axis. So visually, what this is going to look like is we're going to have a circle and it's just going to touch that x-axis at that one point. Now, from the center of the circle to that tangent point is our radius. Okay. So, if we know that that point is -5, 3, that means that we moved up a distance of 3, 1, 2, 3, from our x-axis. So that means that our radius is going to equal 3. Okay. So now we have our center and we have our radius. Okay. So now we've just got to plug in to r squared equals the quantity x minus h squared plus the quantity y minus k squared. So 3 squared gives us 9. And then we have the quantity x minus -5, but again, remember that subtracting a negative is the same as adding. So it's going to be x plus 5 squared plus y minus 3 squared. There's our equation. Alright, now on our next example, they are going to give us the equation of the circle, and we have to draw it. Okay? So, it's important to remember that the equation of the circle is, whoops, wrong tool, is the quantity x minus h squared plus y minus k squared equals r squared. So when we look at that quantity x minus h squared, in this particular problem it's x plus 1. So since the sign changed from a negative to a positive, that means that we were subtracting a negative. So our h right there is actually -1. Okay. Now we need to look at that quantity y minus k squared. In our equation it's just y squared. So that means that our k was actually 0. You're not ever going to write y minus 0 squared because y minus 0 is just y. So you just write y squared. Okay. Okay? So that means the center of our circle is at -1, 0. Okay? And now we also know that r squared is 25. So that means that r is just 5. The square root of 25 is 5. Okay? So let's sketch out our circle. Alright, we have our center at -1, 0, so I'm going to go left 1, but I'm not going to go up or down any. And now I have a radius of 5. So what I typically do is I'm going to go up, down, left, and right 5 units to make myself some points that I can connect. That way my circle looks a little bit better than it would normally. Okay, so if I go over 5 points from -1, I'm going to land at 4. If I go up 5 points, I'm going to land there. Left 5 points, I'm going to land here. And down 5 points, I'm going to be here. Okay. Now I just need to play connect the dots. And hopefully this will be a reasonably shaped circle. Not my best, but not too shabby. Okay? You guys get the gist of what I'm after. Now, in this next example, they give us a picture. We see that circle over on the right-hand side of the screen, and we need to write the equation this time. Okay? So, the center of this circle that they give us is actually at 2, 0. Okay? And we also need to figure out the radius. Okay? So, let's make a little note here. This is at 2, 0. And when I'm looking for the radius, okay, I can just count over to the right, or really in any direction as long as I get to the edge. I'm going to find that to get from the center to this point on my circle, I'm going to count over 5 units. Okay? So my radius is 5, and my center is 2, 0. Now it's just a matter of plugging into our circle equation. Remember, it's r squared equals x minus h squared plus y minus k squared. Okay. So 5 squared is 25. X minus 2 squared plus y minus 0 squared. But when I've got a 0 there, I don't need to write it because y minus 0 is really just y squared. So let me erase that parenthesis too. Okay. And this is our equation of the circle that you see on the right. Now, this slide here is a little segue into our last example. I want to mention to you the technique about completing the square. Okay. When you complete the square, the goal is to form a perfect square trinomial. Okay. Now, the time that you're going to want to complete the square is when you have x squared plus kx. So you're going to have a degree 2 term and a linear term. Okay? And our goal, in order to form a perfect square trinomial, is going to be to find this missing constant that we need to add on. Okay? Now, when we go through this process, and I'll do an example in the next slide, the very first thing we need to do is divide that k by 2. And then whatever the result is, we're going to square it. Then that's going to give us that missing number we need to fill in. Okay? Now, remember that when we deal with this in terms of an equation, there's going to be 2 sides of the equation. Whatever you add to one side, you must add to the other. Okay. So here's our example. We have x squared plus 4x plus y squared plus 2y minus 31 equals 0. And it wants us to determine what standard form is, what the radius is, and what the center is for the circle whose equation is x squared plus 4x plus y squared plus 2y minus 31 equals 0. Now, as they give it to us, that equation looks nothing like the form we're used to seeing it in. So the very first thing we're going to do is write it in standard form, which is that r squared equals quantity x minus h squared plus y minus k squared. So this is where we're going to need to try to complete the square. Now the very first thing we want to do is we want to move this negative 31 over to the other side of the equation. Okay. That's going to give me x squared plus 4x plus y squared plus 2y equals 31. Okay. Now notice that right here that x squared plus 4x is of that form x squared plus kx that I mentioned in the previous slide. So we need to find that missing number that we need to add on. Now remember, if we add it on to the left side, we also have to add it on to the right side. Okay. Now take a look at those y terms. Same scenario, they're just y's now instead of x's. So we can complete that square as well. Y squared plus 2y plus our missing number. But whatever we add to the left, we have to add to the right. Okay. So here is my k. That 4 is my k for that first, for the x terms. So I'm going to divide that by 2, which is equal to 2, and then I'm going to square it. 2 squared is 4. So the missing number that I'm writing in on that first blank is 4. Remember, I've got to add it in on both sides. Okay. Now let's check out our y terms. Here's the k. So I need to do 2 divided by 2, which is 1. 1 squared is 1. So I'm adding in a 1 on the left, and I'm adding in a 1 on the right. Now remember, our whole goal here was to get these into perfect square trinomials, which we have done now. So if I look at the left-hand side, and I look at x squared plus 4x plus 4, I can factor that now pretty easily into x plus 2 squared. Getting a little bit closer now. If I check out my y terms, it's a perfect square trinomial. I can factor that into the quantity y plus 1 squared. Okay. And now over on the right-hand side, I can add up 31 plus 4 plus 1, and I get 36. Voila. You now have your standard form of that initial equation we started with. So, the quantity x plus 2 squared plus the quantity y plus 1 squared equals 36 is your standard form. That's what we're used to seeing. Okay. Now, it also asks me on this slide for my radius. Well, if r squared is 36, then I know that my radius is just 6, because 6 squared is 36. Okay. It also asks me for my center. Okay. Here's my h, here's my k, but pay close attention to your signs. Remember that my original form of a circle has x minus h. So when I subtract a negative, that's what makes a positive. So my h is a negative 2. Same thing over on the y there. It's typically y minus k, but since I have a plus there, it means that it was y minus negative 1. So the center of this circle is at negative 2, negative 1. Alright, that's it in terms of circles. I hope that you learned a lot today, and I will post this video as soon as possible and get the next one up as well.